A year ago, in a video, I said something like this. A year from now, we'll be the best tech channel in the world, but currently, we only have 26 subscribers. However, things didn't go as expected. Due to some reasons, I couldn't upload videos, which hindered the channel's growth, of course. By the way, now I have an assistant named Freddy. He will help me with tasks like preparing graphics and changing music. Anyway, let's get to the main point. In this video, I'll answer questions like, how should you build a computer for gaming or workstation? What should you consider when assembling computer components? How should you choose components? In short, I'll try to address all the questions that might come to your mind before buying a computer. Also, if you're not familiar with computers, you can take notes on what I'm about to explain. It might be a bit confusing to you. Anyway, let's get started. Freddy, can you prepare the graphics?
图形准备好，先生。
Wait a minute.
رسومات جاهزة سيدي.
Los dibujos están listos, señor.
Grafica pronta, signore.
Grafik bereit, Sir.
Graphic の準備ができました。
The graphics are ready, sir.
Before we begin, let me say this. For those who say, I don't understand computers, how do I build the computer after getting the components? There are pre-built computers available. After determining the components at the end of the video, you can check out these computers. Sometimes, there are significant discounts on these pre-built computers. You can take advantage of these opportunities to get the components at a lower cost. Alternatively, if you don't want to deal with pre-built computers, you can buy the components and take them to a trusted computer technician to assemble for a reasonable fee. Now, let's get to the main topic. First, you need to decide on something. Are you building the computer for gaming or rendering? Are you sure? If you're building it for gaming, let's start by choosing the processor. I'll give you a method. First, go to Google and type CPU single-core benchmark list in the search bar and hit enter. Enter the first site that appears, cpubenchmark.net. In this list, you'll see the single-core performance of processors. Don't worry about what single-core performance means or its implications. Just know this. Almost 90% of today's games benefit more from a processor's single-core performance than its multi-core performance. The better the single-core performance of the processor, the better the gaming performance. The processors in this list have decreasing single-core performance from top to bottom. In simpler terms, the processor at the top is better than the one below it. I believe you understand this. Of course, as you go down, the performance decreases, but as you can see on the right, the prices also decrease. Anyway, I want you to choose one of the processors listed here that fits your budget and take note of it. As an example, I'm choosing the 12100F. Despite having fewer cores, it gives high single-core performance, making it suitable for gaming. But remember, we're choosing this processor for gaming. There are more powerful processors that can be selected for rendering. Also, keep in mind that this video is valid for this year. If most games start utilizing the multi-core performance of the processor in the future, then I will update the video accordingly. Now, let's move on to the graphics card. But before choosing the graphics card, let me explain the bottleneck to you. Bottleneck is essentially an imbalance of power between two or more components within a computer. So, I had chosen the 12100F as the processor a while ago, remember? When building a computer, I can't use it with one of the most powerful graphics cards today, such as the RTX 4090. This is because the graphics card would be much more powerful than the processor can handle. The processor can't feed enough power to the graphics card. As a result, in games or programs, we would see significantly lower performance from the RTX 4090 than it should achieve. This is what we call a bottleneck. To avoid a bottleneck, we need to use components that are power compatible with each other. Now that we understand the bottleneck, let's move on to choosing the graphics card. There are two major manufacturers in graphics cards, AMD and NVIDIA. If the graphics card's name includes RTX, GTX, or Quadro, it is produced by NVIDIA. If it includes RX, it is produced by AMD. NVIDIA's RTX series is known for technologies like ray tracing and DLSS. Ray tracing is a technology that calculates reflections in the image, creating realistic images. If you're interested in this technology and consider it a must-have, you have to go with NVIDIA RTX cards because AMD cards currently don't perform as well with ray tracing. In fact, they often perform poorly. But RTX NVIDIA cards have a disadvantage. Their prices are expensive. With AMD cards, you can get similar performance at much lower prices. So, if ray tracing isn't crucial for you and you just want to get high performance at a low price, I recommend choosing AMD RX cards. Now, let's move on to choosing a graphics card. Just like we did with the processor, let's go to Google, but this time, type GPU benchmark list in the search bar. Earlier, we used CPU for the processor. Now, for the graphics card, we use GPU. Keep that in mind. Anyway, enter the site videocardbenchmark.net. The performance of graphics cards on this list decreases from top to bottom. Here, we need to choose a graphics card that fits our budget. I'll pick one of the cheaper cards. I saw the NVIDIA RTX 3060 priced at $330, and below that, there's the AMD RX 6600 XT priced at $290. You can choose either of them. In fact, you can see an example of what I explained earlier here. Despite the RTX 3060 being $40 more expensive, the 6600 XT provides higher performance. I'm choosing the 6600 XT and take note of it. Remember I explained the bottleneck earlier? Well, could there be a bottleneck between the 12100F processor we selected earlier and the 6600 XT? How can we tell? Frankly, this can get a bit complex, so to make it easier, we can just Google it. I'm searching for 12100F RX 6600 XT bottleneck forum. It's a bit of an odd search, I know. We can check any of the forums that appear where this question has been discussed before. As you can see, multiple people confirm that there is no bottleneck. So currently there's no issue with the PC. We can proceed. We've chosen the processor and the graphics card. At this point, for those who want to buy a pre-built computer, our job is done. They can buy one of the pre-built computers with the 12100F and 6600 XT and leave the video. Take care of yourself. Oh, by the way, don't forget that 8 GB of RAM is no longer sufficient for current games. You need at least 16 GB of RAM. When buying a pre-built PC, make sure the RAM is 16 GB or more. Now, for those who won't buy a pre-built PC, let's continue. Today, we've taken it easy enough, but we'll face challenges in choosing the remaining components because there are many factors to consider, such as the case's airflow, whether the graphics card will fit, and ensuring the SSD doesn't have chronic issues. Let's use another trick to simplify and avoid confusion. This time, let's search for the two components we've already chosen by typing 12100 F6600 XT-PC build forum. Let me quickly explain why we're doing this. In forums, there's a discussion environment where everyone can share their opinions about the computer build. For example, after selecting computer components, everything may seem fine, but someone in a forum may tell you that your graphics card doesn't fit in the case, and you may need to choose a different case or graphics card. I want you to search like this to avoid headaches with such issues. Alright, we had searched for 12100 F6600 XT-PC build forum. We can enter any forum site. As you can see, a user shared a link to a PC build they liked. There are no comments indicating any issues with the case. Let's look at the PC they shared. We see that this PC is out of stock, but that doesn't matter to us. We're just going to copy the components. I scroll down, check the processor and graphics card, and they match our selected components. I didn't need to choose the motherboard, RAM, and other components. The person building the PC has already selected them. Bingo! All our components are ready. I've got the names of all the components, but what if there's any problem with any of them? For instance, I can't find the case anywhere, it's out of stock. I choose a new case for myself. Then, I enter a forum site. I create a new post, list all the components along with the new case, and end with this. Hey guys, are the case and other components compatible? Is there any issue? After a bit of patience, I get answers from other forum users. Since the components are compatible and issue-free, we are now ready. I'll buy the components from inexpensive stores, and once they arrive, I'll either assemble them myself or take them to a computer technician. I know I've explained a lot up to this point, and it might seem confusing to those not familiar with computers, but if you have any questions, you can create a post on any forum. To ensure your peace of mind in the future, or to avoid asking yourself, why is my computer giving such low FPS in this game? I recommend taking some time to do research. Anyway, we've assembled our gaming PC. That part is done. Let's take a few seconds to pause. Now, let's move on to the rendering computer. First of all, let me say that I won't go into too much detail when building a rendering PC. We will focus more on assembling a computer for tasks such as video editing, photo editing, 3D modeling, and content creation. This computer will be more suitable for 3D modelers and content creators. I would like to build different computers for other tasks, but I don't want the video to become too lengthy. Now, let's start with the processor. Unlike the processor we chose for gaming, for the rendering computer, we need a processor with high multi-core performance rather than single-core performance. This is because in 3D modeling and rendering, the multiple-core performance of the processor is utilized. Let me explain how this works. What you see here is the moment of rendering the output of a 3D modeled environment. As you can see, each thread in the processor is working to produce the output of the image. The render completion time of these threads determines the multi-core performance of the processor. In other words, the faster the image processing is completed, the higher the multi-core performance of the processor. In fact, animation and visual effects companies use render farms with hundreds of cores just to shorten this rendering time. While rendering a scene in a movie could take months on a regular computer, using render farms can reduce this time to a few hours. So, as you can understand, for these tasks, we need more powerful cores. Moreover, it's not only 3D modeling programs, video and photo editing programs also benefit from the multi-core performance of the processor. This includes programs like Adobe Premiere Pro, After Effects, Photoshop, DaVinci Resolve, and others. Now, let's move on to choosing the processor. First, let's go to Google and type Cinebench Multi-Core Benchmark List. This time, we enter cpu-monkey.com. The performance of these processors decreases from top to bottom. Once again, we face the budget issue, and here I want you to choose a processor within your budget and make a note of it. As an example, I'm selecting the 10-core 12600KF from lower down the list and taking note of it. Now, let's move on to the graphics card. This part is crucial, so pay attention to what I'm about to say. When selecting a graphics card, we need to choose NVIDIA instead of AMD, because the cores named CUDA, found in NVIDIA graphics cards, perform more efficiently in many tasks such as video editing and 3D rendering. Unfortunately, AMD's graphics cards often fall behind NVIDIA in these tasks. Of course, as I said, this information is valid for this year, and if AMD releases new graphics cards that surpass NVIDIA in these tasks, things might change. Anyway, let's proceed with choosing the graphics card. First, go to Google and type V-Ray GPU benchmark list, then search for it. Here, V-Ray is a rendering engine. 3D environments and models created in various programs are rendered using this engine. So, the architectural and industrial images we encounter in our daily lives are created using this engine. After the search, I scroll down and enter benchmark.chaos.com. Here, I click on V-Ray GPU CUDA. After clicking the advanced option on the right, I set the device count to 1 and click on search. A list is formed below with graphics cards ranked from powerful to less powerful. I need to choose a graphics card within my budget. Since the cards on the first page exceed my budget, I move on to the next pages. I see that the RTX 3060 Ti is within my budget, so I note it down. Now that I've selected the processor and graphics card, I can choose the other components using the trick I explained earlier. I entered Google and typed 12600KF RTX 3060 Ti PC build forum. I entered the first site, and my PC is in front of me. Also, I want to emphasize again, please post the components you've noted down on a forum before buying the PC. Find out if there are any issues or incompatibilities. Don't waste your money and time. Now finally, I want to add a bonus piece of information to the video. There is a chronic issue called coil whine in graphics cards. Coil whine is the buzzing sound caused by insufficient inductors in graphics cards. When the graphics card is under load, a low buzzing noise starts to occur. This is not a problem for the graphics card. It doesn't affect performance, but it makes sound. If you are sensitive to these kinds of sounds, it's worth paying attention to this issue. Anyway, let's slowly finish the video. Thank you for watching. If you liked it, don't forget to hit the like button, and if you didn't, don't forget to hit dislike. See you in the next videos. Take care. Goodbye.